Hey guys, welcome back to my channel. In today's video, we are going to find the largest element in an array, right? So let's say an array is given to you 2, 5, 8, 9, 10, or let's give 0. So the largest element is 9, right? So the answer will be 9. Let's say 1, 5, 8, 2. Let's say this is an array given to you. So the answer will be 8 because the largest element in the array is 8. So the most brute force way that comes into my mind is, okay, so this can be a largest element, this can be a potential answer, this can be a potential answer, this can be an answer, this can be an answer, this can be an answer. So let's go to each index and check whether that's the largest element or not, right? So what I'm saying, I will go to this first of all, and I will check in all the other indices whether there is some element that is greater than me, considering that I am the greatest one. So if I found that, while iterating from here till the end, I found that, see, 5 is greater than 2. That means 2 cannot be the largest element, right? So similarly, in the next iteration, I will go here. Then I will again check for all the elements and I will check whether there is some element that is greater than 5 or not. If there is some, 5 cannot be the answer. Then I will check for 8, then I will check for 9, then I will check for 10, then I will check for 0. But we don't have to check for 0 because for 10, I will be getting the answer. How? Because for 10, 2 is less than 10, 5 is less than 10, 8 is also less than 10, 9 is also less than 10, 0 is also less than 10. That means we couldn't find any element that is greater than 10. So we will simply say that 10 is the answer. See, what we are doing here, for each element, we are checking all the other elements, right? So there will be two loops, one inside another. Let's say I is the first pointer and j is the other pointer, and I will check for the ith index. And wait a second, let me go to all the other elements and check whether there is some greater element or not, right? So for this the time complexity will be of n square, but we don't want this. What I am saying, visit one index once only. I mean, if you are visiting 2, don't come and visit 2 again later on. See what we are doing here. Let me just erase this. Okay, so what we are doing here, we are standing at here and we are checking for all this. We are standing at here again, we are checking for all this. We are standing at here, we are checking for all these, right? So what I'm saying, let's not take this. I mean, let's not check for all this for each and every time. So I will be keeping, what I'm going to do, I will be keeping a variable, let's say greatest, int greatest, and I'm keeping some variable in it. Let's say ARR of 0. I'm keeping this value, right? And go and check for all the other indices and get me the answer. But then you will think, bro, if I am iterating for only ARR of 0, I will be only checking for the first index. I will be only checking for the first index. But I am saying, no, bro. The moment I encounter some greater element, the moment I encounter some greater element than 2, I will just say that, bro, there is some other element. So just remove this and keep that element. So let's say, let's do it from the beginning, right? So I'm going to keep something like int greater, let's say that is 2 at first. What is 2? Basically AR of 0, and I'm going to loop from I equals to 1 till n minus 1, and I'm going to check whether there is some greater element or not. So if I found something like AR of I is greater than the great, which basically means I've got a new greater element, right? So if this is true, bro, change this greater because I've got a new greater element. So great will be AR of I, right? So by the end of this loop, I will be having my greatest element. How? See, 2 is there, 2 I have kept, then comes 5. Yes, 5 is greater than the great. So 5 is greater than 2. I'm saying great equals to 5. So let's remove this and keep 5. And for the next iteration, I will be here. It's 8. 8 is greater than great. So change 5 also. Keep 8 here. Then when I will come here, it's 9. So 9 is greater than 8. So change 8 and keep 9 here. Then for 10, 10 is greater than 9. So change 9 and keep 10 here. And for 0, it won't get into this condition. Why? Because 0 is not greater than great. That means great will be storing the greater element. So let's go ahead and write the code. So let's write the same code. Let's keep something like great. Great will be what? Great will be error of 0. See, the thing is, you can take error of 1 also, you can take error of 2 also, but then you will have to compare from 0 till last index. Simplicity, I'm taking error of 0. You can even take like int great equals to int min. So you can take something like int min also, which is basically the minimum value possible in integer range. But you shouldn't give something like 10 or 1000. You can't keep this because see, the elements in the array may be lesser than that. So ultimately you will end up returning this 1000, right? So we don't want that. For now, let's take something that is in the array itself. Integrate. So let's start iterating from int I equals to 1 and then I is lesser than n, I plus plus. I'm going to check for this one condition. If the current element, if it is greater than the grade that we have taken, then change this grade to AR of 1, because see, I have found a new greater element, right? And after this, let's print this grade, and this grade will be giving the result. Let's run this. Okay, so there is some minor mistake. Okay, I have given 5 as the size and I have given 6 elements, right? So let's change that and let's give 6 here also and run once again. So the answer should be 10. Yeah, so the answer is 10. So that's it for the video. If you like the video, please hit the like button, subscribe to our channel. Until next time, see ya.